Okay, so let's get a little bit trickier. What if instead of the shellcode being 12 bytes, what if I said that the attacker wants to execute shellcode that's 28 bytes long? So the attacker wrote some code that they want this program to execute, compiled it into x86, assembled it into ones and zeros, and the resulting machine code is 28 bytes long. Well, now we have a problem, because if you look at this name character array, it holds 20 bytes, and then the SFP gives me 4 more bytes to write, and that's not enough. I have 28 bytes of instructions that I want to write. So try and stare at this picture and think, where would I put shellcode if I can't put it down here? The trick that I did from earlier, where I put the shellcode, followed by some garbage bytes, followed by overwriting the RIP, no longer works. So if you're on the video, you can pause and think about it. If you're in person, you can take a couple seconds and think, where do I put the shellcode? What does the exploit look like now? Okay, so hopefully you had a little bit of time to think about it. So now I'm going to spoil the answer. So it turns out, remember that getAs doesn't have a limit to how much the user can write. As long as the user continues to provide input, getAs will happily continue to write to higher and higher addresses on the stack. So the trick here, the realization is, actually, you know what? If the shellcode doesn't fit down here, I'll just put it up here, above the RIP. So now my exploit looks like this. I now have 28 bytes of garbage, or 24 bytes, sorry. So that's 24 bytes. That's 20 bytes to overwrite the name character array, and 4 more bytes to overwrite the SFP. So there's 24 bytes to write everything up until the RIP. Now I can write an address, and what address? Not too sure yet, but some address. And then after that, I will write the shellcode. And what address do I put over the RIP? That should be the address of shellcode. And if I look at this picture, it seems like the shellcode now lives up here, 4 above the RIP. That happens to be address BFFFFD5C, or I guess BFFFCD5C. Addresses are hard. So that's the address of shellcode. So I'll take that exact address, write it in little endian format, and I'll write BFFFCD5C. That goes into memory, and now when the program's ready to return from the vulnerable function, it looks at this part of memory and says, this is the address that I should transfer control back to. And if I go to that address, there's the attacker's shellcode, and it runs. So it's the same pattern as before. The only difference is the shellcode didn't fit down here, so I put it up here. And that's totally fine because getAs allowed me to write as much as I wanted.